Let's discuss solve problem 3 on singly linked list. The following C function takes a singly linked list as input argument. This is the C function available in front of us. Move to front. This function receives a pointer, that is a head pointer, which must point to some singly linked list, and that to the first node of that singly linked list. Okay. It modifies the list by moving the last element to the front of the list and returns the modified list. What this function does, it moves the last element to the front of the list. Now this is interesting, that is why the name is given, move to front. It moves the last element to the front of the list and returns the modified list. Now here some part of the code is left blank. You can see over here, this part of code is left blank. Choose the correct alternative to replace the blank line. These are the alternatives available in front of us. We need to choose the correct alternative. This question has been asked in GATE CS 2010. I would encourage you to pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. As we know, this function receives some singly linked list. So here, I'm considering this particular linked list. Here this list consists of 4 nodes. And here head pointer is pointing to the first node of the list. This pointer has been passed to this particular function. This means we are passing the whole singly linked list to this function. After this, we are declaring 2 pointers P and Q. Let me declare these 2 pointers here. And then after that, we will check this condition. Is head equal to null or head next is equal to null? That means if we have just 1 node or 2 nodes, then we will simply return the head pointer. Else what we will do, we will put null in Q and we will put head in P. That means we will store null in Q and we will store this address 100 in P. Now you can see that P pointer is pointing to the first node of the list. After this, we will evaluate this piece of code. Here, we will check this condition. Is P next equal to null? If P next is equal to null, we'll get outside of this while loop. Otherwise, we will continue. We can see here that P next is not equal to null. So this condition is satisfied. We'll get inside this loop. First, we will update our Q pointer so that it can point to the first node of this list. That is what we are doing here. Q equal to P. We know that P contains this address 100, which is the address of the first node of the list. Now we want to store this address inside Q. That is why we are performing this step. So here 100 will get stored. After this, we will update our P pointer so that it can point to the second node of the list. Then after that, we will again check this condition. Is P next equal to null? Again, P next is not equal to null. We'll get inside. We'll update our Q pointer so that it can point to the second node. And we will update our P pointer so that it can point to the third node. Now again, we will check this condition. Is P next equal to null? No. I'll get inside Q equal to P, which means we'll update our Q pointer so that it can point to the third node of the list, and we will update our P pointer so that it can point to the last node of the list. Now we can see that P next is equal to null. So we'll get outside of this while loop. According to the question, this function modifies the list by moving the last element to the front of the list and returns the modified list. Some part of the code is left blank. Up to this point, we know how this code works. But what we want from this function is that it must modify the list in such a way that the last node becomes the front node or the first node of the list. So here we have to input something that makes this last node the first node of this list. Let's try to add something to this blank line. For this, of course, we have to update the next part of this node first so that it can point to nothing. That means it must contain null, because we have to make this node the last node of the list. That is why the link part of this node must store null. So we will store null over here. Now we have to make this node the first node of the list. In order to make this the first node of the list, we have to update the link part of this node so that it can point to the first node of this particular list. That is this particular node. We can get the address of this node through head pointer. So here we need just this line of code, that is P next equal to head. Here we will update the next part of this node by this address, that is 100. So we'll store this address 100 over here. After this, we just have to update the head pointer so that it can point to this particular node. Now this node becomes the first node of the list. That's it. So these 3 lines of code is all what we need. So option D is straight away the correct option, let me tell you. And please note that option B is not the correct option. Here the sequence is little bit changed. Let's see what happens when we change the sequence. According to the option B, this is the sequence followed. Q next equal to null, head equal to P, and P next equal to head. These 2 lines are actually interchanged. Here first we are updating the next part of this node, that is, we are making it null. After this, we are updating the head pointer so that it can point to this particular node. Let's update the head pointer. Obviously the head pointer is now updated, but now we have to update the next part of this node as well. How to update this part? we simply lost the reference to the first node of the list. If we try to put this address, we can't put this address in this particular portion. If we try to use this line of code, that is pnext equal to head, 400 will get stored. We know that head is now containing this address, that is 400. So this next part will get updated by 400. But this is wrong. Hence option B is straight away incorrect. So option D is the correct option.